Hey guys, welcome on this second movie of 3.3 and it's about the expansion of ice or why ice floats. First we're going to take a look at what happens at the molecular level and I want to get started with a normal model, and that is for instance argon. And if I cool that, you can see that the molecules go closer and closer and closer next to each other. And when I keep on cooling it, it becomes smaller and smaller. They take less space. How is that the case with water? Well, I'm going to start with a liquid. And the liquid, when we cool it, it gets smaller and smaller. And then if we cool it a bit more, you can see it starts to expand. That's very strange. That only happens with water, that the molecules take more space if they are freezing. It is at 4 degrees centigrade. So it's 4 degrees Celsius. If it is 4 degrees Celsius and it cools, it will expand. That is only the case with water because it forms a crystal lattice, and in water molecules take more space, need more space to form that crystal lattice. So what is that? We have that water, and only water will expand if it is 4 degrees Celsius and or cooler, and it becomes colder. This is because ice has a crystal lattice that takes more space. Okay, and then what happens to the density if we cool if the expansion becomes greater, if we have more volume? Well, what was density again? The density, this rho, this almost P letter, was mass over volume, or mass divided by the volume. If it expands, the mass stays the same, the volume increases, so the density goes down. So ice has a lower density than water. Lower density than water. So what will happen if we have a bucket of ice? If we have the bucket of ice, then if it is above 4 degrees Celsius, then the lowest temperature will be down because it has the greatest density. But if it is 4 degrees Celsius, then this will stay 4 degrees Celsius, and there will be a layer of 3 degrees Celsius, and so on, until we have a layer of ice. And the ice will then float on the water, and that is the reason why we can have ice to skate on if it is cold enough, that we don't need everything frozen. And if you need to ice on a lake or something, you don't need to, and everything doesn't need to be frozen, but only the top layer, and the that makes it that we get a little bit faster. That is faster that we get ice. Yeah, that's it. See you in class. Take care. Stay healthy. Bye bye.